I'm Professor Samantha Robles, and I'm going to teach you how to solve trigonometric equations in an interval of 0 to 2 pi, and to find all the answers in exact terms of pi. Before we start, we will need to use these three tools to solve these equations. First, we will need to rearrange the equation into a simpler form. Two, we're going to use trigonometric identities to further simplify the equation so we can find our answers in terms of pi and on the unit circle. Speaking of the unit circle, you'll need this to find those answers, all right? If you don't have a unit circle, don't worry. Here's one I drew down that you can use. Take time to pause the video to draw it down in your own notebook. Now let's begin. First, we will have to rearrange this equation. First, we will move all trigonometric functions onto one side, so this side can be 0. That way, we will be able to solve this equation. We'll do that by removing cos x from both sides. Don't get confused. This will not remove the cos of the side, because when two functions are multiplied, you cannot separate them. Remember that. It will make solving these equations a whole lot easier. There. This still looks pretty intimidating. We still can't do anything with this yet. So we're going to keep rearranging. And we can rearrange this into a simpler form by using algebraic thinking. How? I'll show you. By transforming this equation into cos x distributed into sin by the power 2x minus 1 equals 0. You're probably wondering, how did you get that? Easy. When you distribute the cos, you'll get this. You'll get sin times cos minus cos. Now, with this form, we can use our trigonometric identities. And for this, it seems that we can use this trigonometric identity. You're wondering, how can we use this? We don't have cos 2. Why is there a 1? Easy. Just like the other one, we can rearrange this in a form where we can apply it to this equation. By doing that, we will swap these two by removing them from both of their sides, which will transform this identity into sin by the power of 1 minus 1 equals negative cos by the power of 2x. Now, you see, now we can use this on this equation. We now know that sin by the power of 2 minus 1 equals negative cos 2, which will transform this part into negative cos 2x. This way, it's pretty easy to further simplify this. We'll just have to distribute the cos with cos 2, which will transform this into negative cos by the power of 3 x equals 0. We still can't use this. We cannot use negative cos by the power of 3 on an interval to find our answers yet. That's not a thing. So we have to keep simplifying it. And to get rid of the 3, we simply will have to square both sides. With that, we get are cos x by itself. 0 squared equals 0. So this side stays the same. You're probably wondering why our cos is now positive. It's because cos is an even function. It's not an odd function. So in the end, cos will always be positive. All right? Now we can find our answers in terms of pi on the unit chart. With this, cos equals 0. And cos is the x-axis of the point. Now let's try to find where cos equals 0. It's 0 at 90 degrees, or pi divided by 2. So here's one of our answers. And cos is 0 all the way down here at 27 degrees, or 3 pi divided by 2. Here's our other answer. There are no more answers left, so this equation has two answers in terms of pi, which, and here they are. You now know how to solve trigonometric equations by fractioning, by factoring. I hope I made solving trigonometric equations way less intimidating for you. I hope you have a nice day.